Physical layer, layer 1. The physical layer is the first and lowest layer of the OSI model. It is responsible for the physical connection between devices and the transmission and reception of raw binary data over a physical medium. This layer deals with basic hardware level aspect of data transmission. Let's see key functions of the physical layer. Number one is transmission medium. Defines the medium used for data transmission, such as copper cables, fiber optic cables, or wireless signals. Specifies the physical and electrical characteristics of the medium. Number two, signal encoding. Convert bits like zeros and ones into signals like electrical, optical, or radio, suitable for the transmission medium. Different encoding systems or schemes, such as NRG Manchester encoding, are used depending on the medium. Number three, data rate determines the speed at which data is transmitted, usually measured in bits per second (bps). Higher data rates requires more sophisticated encoding and error detection method. Number 4, bit synchronization ensures that sender and receiver are synchronized at the bit level. Uses clock signal to match the timing of data transmission between devices. Number 5, transmission mode specifies how the data is transmitted between devices. Can be simplex one way, half duplex two way, but one direction at a time, or full duplex two-way simultaneously. Number 6, physical topology defines the layout of network device and cables. Common topology include bus, star, ring, and mesh. Number 7, line configuration describe the physical connection between devices, either point to point, direct connection between two devices, or multi point. Multiple devices share a single communication link. Number 8, interface standards specifies the standards for physical connections such as connectors, pin configuration, voltage level, etc. Example includes RS-232, V.35 and IEEE 802.3 Ethernet standards. Let's see real-time example of the physical layer. Number 1, Ethernet, wired networks. An Ethernet cable Cat5, Cat6 connect a computer to a router. The physical layer handles the electrical signals transmitted over the twisted pair cables. Standards like 10 base T, 10 base TX, and 100 base T defines different speed and encoding method for Ethernet. Number 2, fiber optics uses light signals to transmit data over a long distance with minimum loss. Single mode and multi mode fibers are used depending on the distance and bandwidth requirements. Standards like 10 base FX and 100 base LX define the use of fiber optics in networks. Number 3, wireless communications uses radio waves to transmit data between devices without physical cable. Standards like IEEE 802.11, which we call Wi-Fi, define the frequency modulation techniques and data rates for wireless network. The physical layer manages the conversion of data into radio signals and vice versa. Serial communication uses serial port like COM ports to transmit data one bit at a time over a short distance. Standards like RS-232 and RS-485 specifies the electric characteristics and pin configuration for serial communication. Number 5, Bluetooth. A wireless technology standards for exchanging data over short distances. Operates in 2.4 GHz ISM band and uses frequency hopping to minimize interference. Physical layer manages the radio signals and ensures reliable data transmission. Let's see challenges and consideration. Number 1, noise and interference. Electric interference and the noise can distort signals. leading to data errors. Shielding cables and error detection techniques help mitigate these issues. Attenuations. Signal strength decrease over distance. Repeaters and amplifiers are used to boost signals in long distance communication. Bandwidth, capacity of transmission medium to carry data measures in Hertz (Hz). Higher bandwidth allow for higher data rates but may require more sophisticated hardware and encoding techniques. Number 3, latency, the delay in transmission caused by propagation time of signal through the medium. Important in real-time application where delay can affect performance. Let's understand the summary of all. The physical layer is the foundation of the network communication, dealing with the physical aspect of data communication. It defines the hardware specification, transmission medium, signal encoding, and other essential parameters that ensures reliable and efficient data transfer between devices. Understanding the physical layer is crucial for designing, implementing, and troubleshooting network hardware and connection. Now let's go through troubleshooting example for each key function of the physical layer. Example issue is poor connectivity over Ethernet cable. Below are the troubleshooting steps which you need to perform. Number 1, check the cable. Inspect the Ethernet cable for physical damage such as cuts or bends. For this, you need to do replacement if necessary. Second thing, test with another cable. Use a known good cable to see if the issue persists. Number 3, verify connectors. Ensure that the connectors RJ45 are properly clamped and seated in the ports. Number 4, check port functionality. Plug the cable into a different port to determine if the original port is faulty. Use cable tester. Employ a cable tester to check for continuity and signal integrity issue. Now number 2, the second function, which is signal encoding. Example, what we get an issue for this signal encoding is data corruption over a wired connection. And here are the troubleshooting steps. Check for interference. Ensure that the cable are not running near heavy electrical equipment which can cause electromagnetic interference, which we call EMI. Number 2, inspect cable quality. Use higher quality cable with proper shielding to reduce noise. Number 3, verify encoding standards. Ensure both ends of the connections are using the same encoding methods and standards. For example, 100 base TX is at both the side. Number 4, replace with the higher grade cables. If using a Cat5 cables, considering upgrade to Cat6 to support better signal integrity. Let's see next function, which is data rate. Issue on the data rate, we see slow network speed over a wired connection. Here are the troubleshooting steps. Check network configuration. Ensure that the network device such as switches and routers support the desired data rates like 1000 Mbps for gigabit Ethernet. Then next is inspect device capabilities. Ensures that both the network interference card (NIC) and the connected device support the same data rates. If there is some change in the data rates, then you will be having issue. Right? Next, update firmware or drivers. Update the firmware of the network equipment and drivers of the NIC for the latest version. Next, reduce network load. Limit the number of devices or application using network simultaneously to reduce congestion. Number 4, which is bit synchronization as a function of the physical layer. Bit synchronization, what issue you face is data loss or error in serial communication. Here are the troubleshooting steps you perform. Check clock signals. Ensure that both the communicating devices are synchronized to the same clock signal. Verify serial port settings. Ensure that baud rate, parity, data bits, and stop bits are configured identically on both the ends. Number 3, replace faulty cables. Use high quality cables to reduce the signal degradation. Okay. Next, Transmission mode. Example, communication issue in hub duplex mode is the issue generally we get in a transmission mode. So troubleshooting steps here: check configuration, verify that both the devices are configured for hub duplex if the network requires it. Next, inspect collisions. Monitor for collision detection and ensure device handle collisions properly. Next, use full duplex mode. If possible, switch to full duplex mode to allow simultaneous two-way communication and reduce collision. Right? Next function, what we have seen is physical topology. Example of issue is like network segmentation down due to star topology failure. Troubleshooting steps: inspect central device, check the central hub switch router in a star topology for the power and functionality. Verify connections, ensure all cables are properly connected to the central device. Next, you see test individual links. Disconnect and test each cable individually to identify fault connections. And replace central device. If central device is faulty, then you have no choice to replace it. Next functionality what we have seen is line configuration. In line configuration, here is the example of issue: communication failure in point-to-point serial connection. Troubleshooting steps: check direct connections, ensure that the device are directly connected to serial cable. Verify pin configuration, ensure that the pin configuration of the serial cable matches the requirements of both device, like RS-232 standard. Use loopback test. Perform a loopback test to verify the functionality of serial ports. And lastly, replace cable. If loopback test also fails, you don't have a choice, you need to replace the cables. And the last function what we have seen is interface standards. Example of issue is incompatibility equipment due to different interface standards. Troubleshooting steps: number 1, verify standard compliance. Ensures that all devices follow the same interface standards like RS-232 or IEEE 802.3. Next, use adapters. If device use different standards, use appropriate adapter or converters. Next, check documentation. Refer to the device manual documentation to confirm compatibility. Lastly, test with compatible equipment. Replace one of the device with a compatible model to test the connections. In summary, by understanding the specific function and potential issue related to the physical layer, you can effectively troubleshoot and resolve common network problems. Scenario what we have discussed is practical approach what we can perform to identify the issue and fix it. So guys, hopefully you understand basics of physical layers. As a security architect, your role at physical layer of OSI model is critical in ensuring the security and integrity of the physical component of the network. Here are detailed examples and explanation of the responsibility and action you take as a security architect at physical layer. Number 1, physical access control. Role: implement and manage physical security measures to restrict unauthorized access to network hardware and infrastructure. Example actions: secure locations. Ensure that data centers, server rooms, network closets are physically secure with locks, biometric scanners, or keycard access systems. Number 2, surveillance system. Install CCTV cameras to monitor and record access to sensitive areas. Number 3, access logs. Maintain detailed logs of who accessing physical locations and when using access control systems. Security personnel. Employ security guard to patrol and monitor critical area, especially during non-business hours. Number 2, environmental controls. Role: ensure the physical environment where network hardware is located is controlled and monitored to prevent damage from environmental factors. Example actions: climate control. Implement HVAC system to regulate temperature and humidity levels in server room to prevent overheating and equipment failure. Number 2, fire suppression. Install fire detection and suppression systems such as smoke detector and automatic fire extinguisher to protect against fire hazard. Number 3, water damage prevention. Ensure that server rooms are not located in flood prone areas and have water sensors and drainage system in place. Number 3, cable management and protection. Role: ensure that network cabling is properly installed, managed, and protected from physical damage and tampering. Example actions: secure cabling. Use conduit, cable trays, and raceways to protect cables from physical damage and unauthorized access. Cable labeling. Clearly label cable to prevent accidental disconnections and make it easier to identify and troubleshoot connections. Periodic inspection. Conduct regular inspection of cabling to check for wear and tear and replace or repair damaged cable promptly. Locking mechanisms. Use locking mechanisms for network ports and cables to prevent unauthorized disconnection or insertions. Number 4, intrusion detection and prevention. Role: implement system and processes to detect and prevent physical intrusions that could compromise network. Example actions: use tamper evident seals on network equipment and cabinet to indicate if they have been accessed without authorization. Motion sensors. Install motion sensors in sensitive areas to detect unauthorized movement and trigger alarms. Alarm systems. Integrate alarm systems with access control and surveillance system to provide immediate alert in case of security breach. Regular drills. Conduct regular security drills and tests to ensure that physical security measures are effective and personnel are prepared to respond to incidents. Now, number 5, securing network equipment. Role: ensure that network equipment such as routers, switches, and servers is physically secured against theft, tampering, and unauthorized access. Example actions: equipment locks. Use rack mounted locks and security enclosure to secure network equipment. Asset tracking. Implement asset tracking system to monitor the location and status of network equipment. Secure disposal. Ensure that old or decommissioned equipment is securely wiped and disposed to prevent data leakage. Anti-theft devices. Use anti-theft devices such as cable locks and security brackets for portable network equipment. Number 6, backup power and redundancy. Role: ensure that network equipment has reliable power sources and redundant system to prevent downtime and data loss due to power failures. Example in actions: uninterruptible power supplies, called UPS. Deploy UPS system to provide backup power to critical network equipment during power outage. Next, generators. Install backup generators to ensure continuous power supply for extended outage. Next, redundant power supplies. Use network equipment with redundant power supplies to enhance reliability. Next, regular testing. Conduct regular testing and maintenance of backup power system to ensure their functionality. Next is number 7, which is physical layer security policies and trainings. Role: develop and enforce security policies and provide training to personnel to ensure adherence to physical security measures. Example in action: security policies. Develop comprehensive physical security policy that outline procedure for accessing control, environment controls, cable management, and equipment security. Employee trainings. Conduct regular training sessions for employee on physical security, best practice and emergency response procedures, incident response plans, and regularly update incident response plans to address potential physical security breach. Audit and compliance. Perform regular audit to ensure compliance with physical security policies and industry standards. At the end, summary: as a security architect, your role at a physical layer involves implementing and managing various security measures to protect their physical component of the network. This includes controlling access to the network hardware, ensuring a secure and controlled environment, protecting cabling and network equipment, detecting and preventing intrusion, ensuring reliable power supply, and developing security policies and training programs. By addressing these areas, you can significantly enhance physical security of network and prevent potential security breaches that could compromise the entire system.